hello everyone. Now we will look at the problem of calculating sphericity of the particles. So, in the question, it is given that the figure shows the scanning electron microscopy images of hematite ellipsoids synthesized by a method called forced hydrolysis, and the average dimensions and average aspect ratio of the particles are given, and we are supposed to calculate and plot the sphericity of the particles as a function of aspect ratio. So, first we will see what is sphericity. So, sphericity is defined as surface area of a sphere to volume of sphere divided by surface area of particle by volume of particle. Where volume of sphere equal to volume of particle. So, it is actually surface area of sphere by surface area of the particle, in which the volume of the sphere and volume of the particle are same. So, okay. So, here we were given the hematite ellipsoids, and it is given that, okay, let us look at the first case where length equal to 57 nanometers and diameter equal to 42 nanometers. So, that alpha is L by T, which is 1.3. Okay. So, volume of ellipsoid is, to calculate sphericity we need surface area of sphere as well as surface area of the sphere which has the same volume as volume of the particle and surface area of the particle. So, first we will look at the expressions which will give us the surface area of the ellipsoids. So, okay. Even before that we will look at volume of ellipsoid. So, the volume of ellipsoid is given by 4 pi by 3 times A, B, C, where A, B and C are the dimensions that we get from the, okay. Let us say that this is an ellipsoid and this is the major axis. So, half of it is taken as A and half of it will be taken as B, and in this direction we have C. So, these are the A, B and C, and if you see when A, B and C are same, we will end up with 4 by 3 pi A cube or B cube or C cube, which means 4 by 3 pi R cube, which is volume of an sphere. Similarly, surface area of ellipsoid equal to 4 pi times AB to the power of 1.6 plus BC to the power of 1.6 plus CA to the power of 1.6 divided by 3 whole to the power of 1 divided by 1.6. And again, if here if we see when A equal to B equal to C, we will end up with the equation very similar to the surface area of an sphere. Okay. So, now we have the expressions for volume of the ellipsoid, surface area of the ellipsoid, and we know the dimensions, and now first we will calculate those. So, okay, even before that, let us look at this case. So, we know that the volume of the ellipsoid is 4 by 3 times pi times ABC, and to calculate the sphericity, the volume of the particle should be equal to the volume of the sphere should be equal to the volume of the particle. So, for pi by 3 times ABC will give us the volume of the particle. It will be equal to an sphere which has an volume of 4 by 3 pi r cube. From this we will get that r equal to ABC to the power of 1 by 3. So, now we will calculate the surface area of an sphere with an radius of r, that is ABC to the power of 1 by 3. So, surface area of the sphere will be 4 pi r square, which is 4 times pi times r, we know it as ABC to the power of 1 by 3. So, r square will be to the 4 pi times ABC to the power of 2 by 3. So, this is the surface area of the sphere. So, now if we write the expression for sphericity, sphericity is usually expressed with an phi s. So, it will be surface area of the sphere 4 pi times ABC to the power of 2 by 3 divided by volume of the sphere, which is 4 by 3, actually it is 4 by 3 pi r cube, but we know that it is the same as the ellipsoid, and we will use the volume of the ellipsoid, which is 4 by 3 times pi times ABC. So, this is the now the numerator, this whole term will be surface to the volume ratio of sphere. And now if we write for the particle, we know that it is 4 pi times AB to the power of 1.6 plus BC to the power of 1.6 plus CA to the power of 1.6 divided by 3 whole to the power of 1 by 1.6. This is the surface area, and we need the volume. Volume is 4 by 3 pi times ABC. So, this and this will cancel out, 4 pi will go, and we will end up with 3 to the power of 1 by 1.6 times ABC to the power of 2 by 3 divided by AB to the power of 1.6 plus BC to the power of 1.6 plus CA to the power of 1.6 whole to the power of whole to the power of 1 divided by 1.6. So, this is the expression we have for calculating the sphericity of an ellipsoid, and now we will just substitute those values. So, for the first case we were given that the length is 57 and diameter is given as 42, sorry it is nanometers, and we have seen that in the ellipsoid A will be L by 2, and we consider that it is symmetric in both the directions. So, B and C are same. So, B will be equal to C equal to D by 2. Yeah. With that, we will calculate the sphericity. So, pi s sphericity will be 3 to the power of 1 by 1.6 times 28.5, which is half of 57 nanometers, to 10 to the power of minus 9 times 42 by 2 is 21. So, 21 into 10 to the power of minus 9 into 21 into 10 to the power of minus 9 whole to the power of 2 by 3 divided by 28.5 into 21 into 10 to the power of minus 18 to the power of 1.6 plus 21 times 10 to the power of minus 18 whole to the power of 1.6 plus 28.5 times 21 times 10 to the power of minus 18 whole to the power of 1.6 and whole to the power of 1 by 1.6. So, this is the pi s, and if we do these calculations, we will get 0.9845. So, when sphericity is comes out to be equal to 1, that means we have an exact spherical particle, and here we are getting a value of 0.9845, which is very nearer to 1. And if we see the images in if you see the images of a first one where alpha equal to 1.3, they look very similar to spherical particles. They deviate a bit from sphericity. So, that is why we see this deviation from 1, and we did not get the exact value of 1. So, pi s is 0.9845 for the first case, and similarly if we calculate for the second case, pi s will be 0.9397, and for the third case pi s will be 0.9179. For fourth case, pi s comes out to be 0.8714, whereas for the fifth case it comes out to be 0.7672. So, these are the different sphericity values for different aspect ratio of the particles, and we see that when aspect ratio is being increased, we see a decrease in the sphericity. So, that is the last part of the problem. We are supposed to plot sphericity versus aspect ratio. So, it is 0, so it is 1, 2, 3, 4, 5, and the y axis we will the values that we have got is in the range of 0.76722 to 0.9845. Okay, then we will take from 0.7. Let us say this is 0.7 and this is 0.8, 0.9 and 1. So, in x axis we have aspect ratio and y axis we have sphericity, and for the first one the aspect ratio was 1.3 and comes out to be here 1.3. For that the sphericity is around 1, which is 0.9845. 0.9845, something around there. And the next one we have the aspect ratio 1.7. So, there 1.7 and the value is 0.9397, we can take it as 0.94. So, which is around there, and then for the aspect ratio of 2.1, we have got the sphericity to be 0.9179, which is 0.92, which is around there, and then 2.7. For the aspect ratio of 2.7, we have got the value to be 0.8714, 0.8714, something like that, and the final one, the aspect ratio is 4.2, and we got the sphericity to be 0.7672, which is around, yeah, which is around there. So the line looks something like that. So this is the plot of it need not to be a straight line, but if you plot the sphericity versus aspect ratio for different shapes of particles, this is how we obtain. Thank you.